stellar proper motion, which is here. You can find it in the modules, lab 5. And if you go to assignments, you can also find it here after Starlight, of course. Is the only session we're having this week is a half lab. Okay. If you have already submitted this lab, you probably don't need to worry about today or Wednesday, because the next lab we're going to start it on Monday, which is the H&R diagram. That will take us 2 to 3 days, and then we'll do the black hole outline, which should be right before the spring break. After the spring break, we're going to be doing some of these labs. And then on April, these 2 or 3. So we're good with labs. That's why I'm not worried about Wednesday. Like, we're not going to miss anything. Now, with the stellar proper motion, when you open the lab, you will find that you are going to be studying the radial and transverse or tangential velocity of a star, and then you have the two velocity. It's basically vectors, and that's the resultant. So the proper motion is given by the angle it moves per year. So stars in the night sky. So let's suppose I have it like that. If I have my date and time and I move it by 1 year, see that there is a small motion. It's not very noticeable. So that's why we say that stars are in fixed positions and planets are the ones who move, right? That's what the Greeks realized. We start realizing this more if we go by decades. Right? Look when I start going like that. So you will notice a small change as we see the ray ascension and declination. The ray ascension and declination are the coordinates on the celestial sphere that we use to locate objects in the night sky. Think it in terms of latitude and longitude on Earth. Latitude and longitude are the vertical and horizontal lines. You know, the latitude are parallel to the equator, and the longitudes are the meridians. The prime meridian is the one that goes through the Greenwich meridian, the one that divides the Earth from east to west. So that's where you have the time zones and all that. So the latitude and longitude are used to locate points on the Earth. For the stars, constellations, and planets, we use the ray ascension and declination. So a positive declination, as you see here, is telling you that the object is located above the equator. So you are located in the northern hemisphere. So that makes sense, right? We're looking at it from, I'm right now in orange, so I can see it from there. Now, let's take a look at the instructions. So you are going to go into 1916, 2 years before the stupid pandemic, that 1918, right? 31st of December on the 000. Okay? So make sure you are there and you make sure you stop time. Here, has to be a stop. See? You want to locate this object, which is here. And you want to make a field of view of there, between 0.5 and 1.5. And they tell you that in this frame, you can find or you can locate Barnard's star. And they're asking you to go from 1960 to 1996 and then change back and forth over the 80 years and see the motion of Barnard stars relative to the background stars. So that's observational, right? So if I do this, Where is Barnard star, by the way? Let's go down. You see this star here? That's Barnard's star. And if you go to 1996, let's see. There's some sort of motion, right? It was there. Now it's here.
Yeah, it moved to the left.
Yeah, so that's what you expect, but that's what in a period of 80 years. So that's quite a lot to notice. A lifetime, basically. You're gonna return to 1916. You're gonna center on Barnard's star, right? You press the space bar, and then you are gonna write down the ray ascension and declination. But there are two. You wanna write the one that says on date. So on the given date. 17 hours, 53 minutes, 45.10 seconds. And the declination is 4 degrees, 27 arc minutes, 48.1 arc seconds. So you are going to do that. You are going to record that in a period of every 10 years. So you're going to advance every 10 years. I'm going to record all that in this table. So far, you can probably do all that in the online assignment. The rest you cannot, like, for example, the plot. Now, how are you going to plot? Since you have hour, minutes, seconds, degrees, minutes, arc seconds. So you see this formula here? You are going to convert the ray ascension and the declination both into decimals. So let me give you an example. 1916, 1231. Let's write down here the ray ascension and declination, like you will do in the lab. So you go here, and you go to 1916, can do it like that, ray ascension, and it's 17 hours, 53 minutes, 45.10. Be careful with that, you read the one on date. And the declination is 4 degrees, let's put it like that, 27 arc minutes, and 48.1 arc seconds. How to convert to decimal? It's all recorded, so you can always go back. You're gonna do 17 plus 53 over 60 plus 45.10 over 3,600. Because there are 60 minutes in 1 hour, 3,600 seconds in 1 minute, in 1 hour. And then you want to use a calculator, right? So here, I open there. Wait a second. And then, okay. So 53 over 60, that's that. In fact, you maybe want to do this. You can put parentheses here. 53 over 60, parentheses, plus, parentheses, 45.10 over 3,600. There it is, right? That's the answer. Now you add to 17, and there you are. So the decimals of the ray ascension on this particular date. So now you have the answer for the first conversion. So you can always check it out if you're doing it correctly, right? In decimal, will be 17.896. How about the declination? The declination is the same. You will do 4 plus 27 divided by 60 plus 48.1 divided by 3,600. The declination decimal will be, so again, parentheses, 27 over 60 plus 48.1 over 3,600. So I get that 4.46 free. All right, and then you write that down here. There it is, decimal. So you want to write down in here. That's why you need this table. I don't think you have that. Actually, no, you have that also in the assignment, but
Yeah, the table is in the assignment.
but it's not pretty obvious what you have to do though. So I know some students make mistakes in that. Okay, yeah. So you have to. They don't let you write this down, so I cannot see your mistake if you guys made this wrong. So at least you know the answer for the first row. You have to scan. So at least here, you can actually scan a picture of your graph here. Okay.
So
That graph?
Huh? Yeah, you have to do a graph of this. So that's why you convert it in decimals. You may want to use Excel for that. Okay, if you use Excel, it's probably much easier. You will plot declination in the y-axis, right ascension on the x-axis.
And then we'll
Scatter
just
plot.
use like the points to plot a line, I guess.
Yeah,
Okay.
these points here.
Professor,
Yeah.
so can I do like that chart on the quiz version, and then like when it comes to like scanning the picture, if I can't like take a picture of it from my notebook, can I like send it to you as an email?
Yeah, that's what some students have done already. You can do it like that. You can use Excel. You can do anything. It's basically these are the main
Hi,
exercises. The
what
plot and the table.
the last lab that we handed in was due today, right? The Starlight lab.
Was it? I don't think so. Well, I don't know. They're still open anyway.
Hello?
Yeah.
Okay, yeah. It was a Starlight lab that was due today, right?
Well, you already submitted it, and like it's still open. So, but it was due February 26th. It was due on Friday.
Oh.
But
Alright,
that's
yeah,
okay. They're, and I left them open, so in any case, it will just show late. This
no,
one is
it's
due on
alright.
Friday.
Right. I already submitted it to you.
The Starlight?
Yeah, and you graded it, so.
Yeah, yeah. And Stellar Promotion is due on Friday. So you have, all right. Remember, guys, Wednesday there's no lab. Okay, we're just doing it today. And if you have any questions on Wednesday, if I'm free, I'm gonna try to answer them. Maybe late afternoon. Okay. The next lab is the H&R diagram. We're gonna start that on Monday. Make sure you are early for this lab. There's no online submission. You have to do this by paper. So I think what you should do is you may want to start printing this lab. Look all what you have to do. A lot. Okay. So that's one of the main labs this semester is H&R lab. Okay. So this is a good, easy lab today as a warm-up for the one that is coming. Okay, any questions about today's lab?
Yeah,
The stellar proper motion one.
I'm having some problem.
No
So
issues?
it's telling me to look up the star HIP 87901.
Yep.
And then I looked it up, but it's literally just pointing to the ground.
And you have to remove the ground.
How do I do that?
Remove the ground, remove the atmosphere, remove the ground, remove the cardinal points. Don't put any.
Lower
You see, your screen
lower
should look like
12
my screen right now.
I got it.
All right,
But
guys.
it's also asking me to change the FOV.
You have to zoom in with a mouse.
Oh, okay.
Wait, Professor, for this stellar proper motion lab, you said it's due Friday, right?
Yeah.
Okay, and
It should be due
I'm just
today,
wondering.
though. I'm being very nice with you guys.
Yeah. Yeah. Wait, so I'm wondering, like, can I do the lab like just by myself? Like, I mean, like
Yeah,
just
right
follow
now,
the.
there is a couple of students who have done it by themselves, huh? And they did really well. I mean, some numbers are a bit off, but
No, I
if
mean,
you
like,
have the instructions right now, you can do it on your own time.
so all the instructions are on the lab itself. Like everything I need is there. Right.
We're doing the tutorial I was giving right now. I mean, did you hear what I said about like some of the tips?
No, sorry, I just came in like 2 minutes
I
ago.
mean, everything is in there, but I gave some tips on how to convert the right ascension and declination. Make sure you're using this right ascension, the one that says on date. Barnard's star is this one here, this HIP. You find Barnard's star just there. Make sure your field of view is between 1 and 1.5.
Okay, but this is all in your tutorial, right? Your video tutorial.
Yeah, that's right.
And the next lab you said is the H&R lab next Wednesday?
This coming Monday, so in a week.
Oh, next week. Okay, so this one's the stellar prop promotion one's due Friday, and then the one you said we can't be late for, the next one is on Monday.
Yeah, and for that I might give you guys 3 days because I want to do the video, or maybe I give you guys, when is your spring break? This week, right? So you have to do the video before spring break, the black hole video. Then you go on a spring break, and then I have something for you guys prepared for the last week of March. Okay. Yeah, so we are actually really good because then we have 3 more labs. Yeah, perfect. How are you guys doing with the lecture?
We just presented
Yeah.
projects.
Huh?
We just presented